Hello everyone, and welcome to video B on related rates. We're going to start today with question number 6, which says, an object moves on a parabola, 3y is equal to x squared. When x is equal to 3, the x-coordinate of the object is increasing at a rate of 1 foot per minute. How fast is the y-coordinate increasing at that moment? So realize that your first goal is always to identify your variables. So the fact that the x-coordinate is increasing at a rate, they're talking about dx dt. They want to know how fast the y-coordinate is increasing. That would be dy dt. So I'm sure you've realized by now there's always going to be 3 parts to your chain rule. So what are we capable of finding? We're capable of finding dy dx. So it's up to you whether or not you divide by 3 first. Most people choose to do that. Y is equal to x squared over 3, or even easier, 1/3 x squared. So dy dx is equal to 2/3 x. So I see my 3 parts, and I can put them together in a chain. Dy dt, I need another dt on bottom, so I'm going to put that over here, so I will have another dt, but now that must mean I need a dx on bottom, because I need the dx's to cancel, and I need a dy on top, which I have. So dy dt is equal to dx dt over dy dx. So I fill in all the pieces. Dy dt is equal to 2/3 x dy, sorry, that was backwards. Well, I just reversed it. Actually, I am going to reverse it. It makes more sense. 2/3 x, and then I'm going to put this one here, dx dt. So if you want to know dy dt, you can just plug in any point x and its rate at that point. So where do we want to know it? At x is equal to 3, they said the y-coordinate is the x-coordinate is increasing at a rate of 1 foot per minute. Those are the 2 things that you need to know to find how fast the y-coordinate is increasing. So while this is your general rule, you can make it into a specific one if you have an actual point. Dy dt at x is equal to 3 is 2/3 times 3 times 1, which is equal to 2 feet per minute. That's it. Number 7. It's a little bit similar. If an object is moving on a curve, y is equal to x cubed, what is the y-coordinate of the object? At what point is the y-coordinate of the object changing 3 times more rapidly than the x-coordinate? So the rate of change of y can be expressed as dy dt. The rate of change of x can be represented as dx dt. Although what can we find? We can find dy dx. So I'm going to put these 3 together. It's going to be the exact same chain rule as last time. Dy dt is equal to dy dx times dx dt. That's the little puzzle you have to put together. But their question is, when is the y-coordinate changing at a rate 3 times the rate of the x-coordinate? So their question is, when is the y-coordinate change 3 times the rate at which the x-coordinate is changing? And that's going to be key, because I can't do this with 2 different parts, but I can substitute in 3 dx dt where there used to be a dy dt. I just realized that doesn't go there. Oops. dy dx is the 3x squared. And now I'm going to put 3 dx dt. See that? So dy dt, I'm going to replace with 3 dx dt, because that's the exact point that I want to know, times dx dt. I have it on both sides, so I can divide both sides by dx dt. I'm sure most of you aren't actually showing this step. You're just going like this. But now you can see algebraically why it's true. And that gives us 3 is equal to 3x squared. X squared is equal to 1. X is equal to, don't forget your plus or minus. You don't want to not have both answers. So it says at what point. Make sure you always answer the question. So your answer should be a point. How do you find the y? Whenever you want the y, use the y equation. I know that sounds a little oversimplified, but it will help you get it right. So since y is x cubed, 1 cubed is 1, and negative 1 cubed is negative 1. So let's just take a quick minute and look at that on the graph. And you should always be thinking about whether or not your answers make sense to you. So here's my cubic graph. And so apparently at 1, and at negative 1, negative 1, the little slope right there is, well, we already know that the slope dy dx at 1 is 3, at x is equal to 1 is 3. So right there, the slope is 3. So think about that. If that slope is 3, it's a ratio of 3 to 1. What does that mean? It means the y coordinate is changing 3 times what the x coordinate is changing. And same thing here. The dy dx, the slope at x is equal to negative 1, if you plug that in, is also 3. So it's 3 to 1. The y coordinate is changing 3 times as fast as the x coordinate. So even since you were younger, you've always known that slope is rise over run. It's the change in y over the change in x. Slope is change in y over change in x. Change is derivative, dy dx. So if you're just now making that connection, that's a good day to suddenly be getting that. Okay, so this video has 2 questions left. I know that doesn't seem very long for related rates B, but these 2 are often mixed up. So I not only want you just to think about these 2 problems, but think about them in relationship to each other, because they're going to sound very similar. Number 8 says, a balloon rises vertically at a rate of 5 feet per second. So here's my balloon. It's rising. So if we call it, like usual, a vertical distance y, then the dy dt is the rate at which y is changing. And since the balloon is rising, it's positive 5 feet per second. A person on the ground 200 feet away, so here's 200 feet. Here's my man on the ground. He spots the balloon and he watches it ascend. At what rate is the distance between the balloon and the observer changing? So if this distance is h for hypotenuse, their question, at what rate is this distance changing, is dh dt. What is dh dt? So it's changing at a different speed when the balloon is down here than it is up there. So they're going to want to know it when the balloon is 50 feet, but that when, remember, we always save for the end. So we do want to just find dh dt in general, but at the end, we're going to want to know it at 50. Okay. All right, let me just not have too many things on my picture here, so I'm going to erase this one. So this is actually very similar to the ladder problem. The thing that connects all these pictures is going to be x, we'll call this x. X squared plus y squared is equal to h squared, which means we can use our little implicit differentiation trick. So x squared is going to be 2x, taking the derivative of everything with respect to t. 2y dy dt is equal to 2h dh dt. So this is my general formula. Now I'm going to actually figure it out when y is equal to 50. So I have my 2, my x is 200. My x is always 200, which means what about dx dt? How fast is the x value changing? It's not changing. It's always 200. This man isn't walking forward. So it's going to be 0. Y is 50. They said they actually specifically want to know this answer. When y is equal to 50, the balloon is 50 feet off the ground. And how fast is the balloon going up? 5 feet per second. It's positive because it's rising. Now, we are going to have to find h at that moment, but this we're not going to find. This is what we're looking for, but we need to fill this in. So at the moment, at y is equal to 50, x is equal to 200, and you can find h at that moment. How do we do that? With the Pythagorean theorem. So we have 50 squared plus 200 squared is equal to h squared. So, I know you guys aren't doing it. You're just going to wait for me to do it, aren't you? That's okay. If I were a student, I'd be waiting for me to do it too. So h squared is equal to 42,500. And so h is equal to, so this is interesting. You really don't want to round here. It is equal to 206.155, but you need to leave it as the square root of 42,500 because you're still doing a lot of math to it. Or you can take this answer in its entirety with all its decimal places, and you can store it as x in your calculator. But whatever you do, don't put the rounded answer at this point because you still have to divide. First of all, that goes away. You still have to divide both sides by 2 square roots of 42,500. It's going to affect your answer quite a lot if you put a rounded number there. And if you're an AP and you do all this work and you're not right to the nearest thousandth, you won't get credit for the problem. So this is 2 times 50 is 100. 100 times 5 is 500. So we're going to do 500 divided by, and if you've stored that as x, you can say divided by 2x. Stored as x. Sorry, you have to wait for me to do it. 500 divided by 2x. And I get 1.212678. So 1.213 feet per second. That's how fast this distance is changing when the balloon is 50 feet in the air. So number 9 is not only extremely similar, I'm just going to tell you right now, I'm guaranteeing you that when you take your test on related rates, this question will be on there with different numbers, of course. So you're going to have the ability to pick. I'm going to give you 7 questions. You're only going to have to pick 5. If you want to be guaranteed to know one of the 7, this is it. So if you pay attention and you can understand this problem, it'll really help you. So again, the balloon rises vertically. This time, our balloon is rising vertically at a rate of 10 feet per second. So dy dt is equal to 10, where this is y and this is x. A person watches the balloon ascend from a point on the ground that is 100 feet away. This 100 never changes. X is always 100. And so dx dt is going to be equal to 0. At what rate, here's the giveaway, in radians per second is the observer's head rotating? So try and understand what's going on here. You got this person that's standing here. My pen doesn't want to draw that small. And they got a lot of hair, I guess. And their head is turning upward. So think about it like this. You're looking at the balloon, and then the balloon rises. What do you have to do to your head? You have to tilt it so that you can keep seeing it. So there's an angle that's going on here. First, you're looking straight ahead, and now you're looking up. There's an angle that's happening there, and that's what they're talking about. They want to know what angle, how fast that angle is changing. And if for any chance you're thinking, this is so unrealistic, well, it's not. There's all kinds of automated things, whether they be motion lights, something as simple as motion lights at your house, or something as complicated as sensors in space, that are definitely trying to track things, and they need to know the speed through which the angle rotates. So we are doing a very simplified version of something that's very important. So the question is about this angle. So think about the last one. The last one, we wanted to know about the length, and we knew this length, and we knew this length. So we came up with a formula that involved the lengths. This time we want to know about the angle, and we know this length and this length. Can you think of a formula that involves this angle and these two lengths? I know somebody is actually talking to their computer going, I know it, it's tangent. It is tangent. Tangent of theta is equal to y over x. This is your formula. But it does have 3 unknowns, so we're not capable. This is single variable calculus. We cannot work with 3. We just need y is equal to a single variable. But fortunately, x is a constant. So don't worry. One of them will be a constant at this stage in your calculus career. And then I can change it to y is equal to 100 tangent of theta. Now, if I take the derivative, it's not dy dx, it's dy d theta. So that gives me 100 secant squared theta. That's dy d theta. So what else do I need? I have a chain rule going on here. So let's see, what do I have? I have dy dt, I have dy d theta, and what are they asking me to find? At what rate is the observer's head rotating? They want the rate of change of theta. They want to know how theta is changing. So can I put these 3 things together to make a chain? Absolutely. Let's see, the dt's on the bottom here, and it's on the bottom for this one. So they have to go on opposite sides. And I have a dy d theta. So I'm going to put that here on this side because I need it to cancel the other d theta, right? And that'll give me dy dt is equal to dy dt. So I know I've made my chain rule correctly. There's my chain. It's like a little puzzle. You got to put it together. So d theta dt is what I'm trying to find. And by the way, that is where people go wrong with the chain rule. They start with what they want to find. They're like, okay, I need to find d theta dt. What is that equal to? And then they try and make a chain, but sometimes the thing you're trying to find is in the chain. So you can't just, that's why that doesn't work to just always start with that. Times dy d theta, which is 100 secant squared theta, is equal to dy dt. So I can say d theta dt is equal to dy dt, whatever that is, divided by 100 secant squared theta, which I actually personally am just going to simplify a little bit. I'm going to make it 1 over 100 because I think that that's always easier. And I'm going to move that to the top and call it cosine squared because cosine's always easier to find than secant. And then times dy dt. So a little bit different form, but I think that you'll find it's easier. You're used to multiplying by the derivative at the end, right? So now I have a general formula for d theta dt, meaning if you tell me what theta you want it at, I can tell you how fast it's moving. So when it's down at the bottom, right, it's moving differently than when it's at the top. It has a different rate. So we want specifically dy d theta at, what do we want to know it at? When the balloon is 50 feet. Oh, they didn't give me theta though. What did they give me? They gave me when y is equal to 50. So what I really need right there is when theta is equal to something. But we can actually work with this. This is okay. Because, I'm just going to give myself a little more room here. It's okay because we actually don't need to find the angle in order to find the answer. Do you know how to find cosine of theta if you know that this is 50? If this is 50 and this is 100, can you find cosine of theta? Well, cosine of theta is equal to adjacent over hypotenuse. So you could figure out what theta was and then do cosine of theta, or you could just say cosine of theta is adjacent over hypotenuse. So we do need to find the hypotenuse. How are we going to find this side? 50 squared plus 100 squared will give you your hypotenuse squared. So 2,500 plus 1, 2, 3, 4, 10,000. So 12,500 is equal to h squared. H is equal to the square root of 12,500. Again, you don't want to round that yet. So cosine of theta is 100 over the square root of 12,500. So think about that. 1 over 100. I need cosine theta to go right here. Instead of actually finding theta, I can say, well, I found cosine of theta. Cosine of theta is 100 over the square root of 12,500. Think about that again. There's 2 ways to find cosine. If I say to you, what is cosine, and I give you the angle, like pi thirds, then you can say, oh, it's 1/2. But if you don't know the angle, the other way to do it is to do adjacent over hypotenuse. As long as you have a picture of the triangle, you don't need to have the actual angle. So that's what I did. I did the adjacent side over the hypotenuse. So 1 over 100 cosine squared, be careful, times dy dt, which they gave me. They told me that the balloon was rising at a rate of 10. So this is a lot of math in here, but this is why you don't want to round that square root of 12,500. If you would like to, I know you're just going to type it in your calculator, but if you wanted to simplify it first, or you can just type in your calculator, it's 100 squared over, notice that the square root cancels, times 10, and then this 100 and this 100 cancel, and then you have 100 times 1,000. So you have, or 100 times 10 is 1,000. 1,000 over 12,500. 2 of the zeros cancel. 10 over 125. Divide by 5 is 2. I don't know why I feel like I have to do this math. Divide this by 5 is 25. 2 over 25. There you go. What's the unit? Huh. Good, they gave me the unit. I don't have to figure it out. They actually said at what rate? In radians per second. So 2 over 25 radians per second. Okay, super long problem. There is, as you can see, one like it on your homework, number 13, that you can practice on to make sure that you get it. All right, that is it for Related Rates B, which is the end for the honors class. Have a great day.